If you're looking for a solution allowing your developers to have dedicated clusters without the need of provisioning any extra resources, then this episode is for you. Welcome back to Is It Observable? Today's episode is going to be part of the Kubernetes series where we covered already lots of episodes. So how to collect logs in a various way, what is the gateway API, how to auto-scale your workload, the power of Kubernetes events, and way more. Today's episode will be focused on a CNCF project that allows us to create virtual clusters within a real cluster to code, to test, or to do any type of activities, in fact. And I'm referring to Vclusters. So the main question that we'll try to answer today, can we observe a virtual cluster? If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what we're going to learn out of this episode. We'll start with an introduction, reminding the various needs that we have when we test, when we code our applications. Then we will explain what is Vclusters, and we cover different aspects. So how are the resources shared with Vclusters? How does the network work? How to limit resources of our virtual cluster, how to access our virtual cluster, and how to observe it. And as usual, at the end of this episode, we will do a tutorial. When building our applications that will end in a Kubernetes cluster, there are several ways of testing it in a development environment. If we only test one single component, then we don't have any issue to run any tests. We can simply use our local IDE to run those tests. What about tests that requires dependencies, such as external components of a messaging broker, for example? For that, we usually have temporary dev clusters that are usually been designed to build and run our unit tests and integration tests in a dedicated environment. Again, it could be a permanent dev environment or a purely ephemeral environment. Permanent environments are convenient, but can clearly be considered to be very expensive by our organizations. That is why we now often rely on ephemeral clusters that we spin up only when we need it, and then we destroy them. But what about having a local environment to deploy our application, or at least most of our dependencies? Well, to do that, we can either rely on a local Kubernetes flavor like Minikube, Kind, and others, but sometimes running locally a cluster could require lots of resources to be able to deploy our components and all the dependencies. So that is the reason few developers are using Docker Compose to have a smaller environment running in a Docker environment. But it means that we need to build a specific Docker Compose YAML file that will be only used for those type of technical tests. What? But even with Docker Compose, depending on the environment that we are planning to spin up, it could require lots of resources. We usually don't have enough CPU or memory on our laptop to host that kind of environment. Otherwise, few organizations have big dev clusters and are creating dedicated namespaces for each developers. That could work, but it adds extra work for us. So we have to make sure someone is operating those dev clusters and the various namespaces. We have to make sure each individual namespace are properly configured and so on. And again, if you want to simulate a deployment with components sitting in separate namespaces, then it starts to be complicated. That is the reason a few years ago a CNCF project has been created allowing our platform owners to provide temporary clusters within our main dev cluster. But how can I create a cluster in a cluster? Well, this is possible by relying on a solution named Vcluster. Vcluster is an amazing solution that I'm using quite often to build tutorials for this channel. Vcluster allows me to test or explore solutions without having to create a dedicated cluster for each topic. So for me, it's just perfect. And at the end, Vclusters allow us to create a virtual cluster in a real cluster. In fact, you can also create Vclusters within a virtual cluster. Okay. So how does it work? When working with Vcluster, you will have the host cluster that will host our virtual cluster or clusters, and of course, the virtual cluster itself. So when creating a virtual cluster, it will first create a dedicated namespace in the host cluster for the new virtual cluster. Then it will deploy a stateful set to manage our virtual cluster. This stateful set will have two containers, the control plane with the virtual cluster, so it means the API server, the data storage with etcd, the control manager, and you can also have a scheduler, but it's an option. It depends on how you deploy your virtual cluster. The control plane at the end is a Key3s cluster. The second container is the syncer. It will be in charge of syncing the resource created in the virtual cluster into the host cluster. How can we deploy and create virtual clusters? There are several ways of doing it. With a Vcluster CLI, I would say it's the most easiest way of creating virtual cluster and be able to interact with them. Then the second option is Helm, and last, kubectl. Vcluster CLI will make our life easier when it comes to connecting, disconnecting, and more actions in fact. But to configure the virtual cluster, it will mainly be done using Helm or a value file with the help of the Vcluster CLI. Every time we deploy a workload in our virtual cluster, the workload would also be available in the host cluster. In the namespace created in our host cluster, we should find all the workload created in the virtual cluster. The naming of the pod will be slightly different from the virtual cluster perspective because it also adds in the name the notion of namespace. To be clear, you will only see the pods, the services, the config map, the secrets, the PVC of your workload. We won't see the deployments, the stateful sets, or any CRD created in the virtual cluster. Vcluster syncer is creating only on the host cluster the components required to run the workload within the virtual cluster. So it means pods rely on containers, so they will end up in the host cluster. If the pods requires secrets or config map or PVC, then it will also end in the host cluster. The services are created to let resources from the virtual cluster reach services in the host cluster. But you will see it requires a specific configuration. When creating the virtual cluster, it will by default use the host scheduler. But you will also configure your virtual cluster to use its own scheduler. So the question is, why would I need to use my own scheduler in the virtual cluster? Well, it depends on what you're trying to achieve. So let's have a look at the scheduling to answer this question. In the virtual cluster, if I run kubectl get nodes, I would see the nodes provided by the host cluster. But if I start, for example, to label those nodes in the virtual cluster, the host cluster won't have those labels. They are technically only labels in the virtual cluster. Because by default, the virtual cluster use the host scheduler, all the deployment using a node selector with my custom label won't work because we use the host scheduler. And in fact, it will be the same story for taints and tolerance. So if you need to test deployments having a node selector or taints and tolerance in your virtual cluster, it would make sense to enable the scheduler with your virtual cluster. To enable the scheduler on the virtual cluster, you will need to configure properly your virtual cluster using the value YAML file that will enable the scheduler. So here is the right settings. Working with virtual cluster, you may expect to be able to synchronize the resources of the virtual cluster on specific nodes having specific labels or taints or tolerance. That is also possible to create or update the virtual cluster by asking the Vcluster to add specific node selectors or taints in the pods that will end in our host cluster. So here is the reference of the settings to enable the node selector. And here is the settings for the taints and tolerance. The other important aspect is the network and the DNS. How is the network being managed by the virtual cluster? So as explained, our pods will end in the host cluster. In fact, because actually we need real resources to run the workload of our deployments. As you know, when you deploy and create pods, you also allocate IP addresses, ports on the node. So it means the networking allocation would also be done the same way. I'm creating a services, then I would have the equivalent services that will also be created in the host cluster with the help of the syncer, which means the cluster IP address of the services creating in the virtual cluster will be the one allocated by the real services creating in the host cluster. Vcluster comes with its own DNS, so core DNS, so all the standard networking feature will work properly for all the resources available within the virtual cluster. It also means that the virtual services cannot reach out to a host services. The DNS resolution won't be done. It will be the same on the other way. So host services cannot reach the virtual services. If needed, there is an option allowing us to create mapping roles helping us to expose host services in the virtual cluster. Let's say we have a service A in the namespace A of our host cluster, and we want to map it in our virtual cluster. It would allow to call this service from pods or services running in the virtual cluster. This is useful, for example, if you want to reuse components and services that are deployed in the host cluster into the virtual cluster. So let's say, for example, the open telemetry collector. I don't have the need to deploy X open telemetry collectors into X virtual clusters. So here is the settings to configure the virtual cluster with the right mapping role. So from host, we define the namespace and the service we want to map. And then on the virtual cluster, which namespace will be sitting this new service and the virtual name of the service. You can also do the opposite, where you can expose a service available in the virtual cluster into the host cluster. You will have to create another type of mapping rule. So here is the example. So from the virtual cluster, where we define the namespace, the virtual namespace where this service is sitting, the name of the service, and then only the service name. Because at the end, we don't specify the namespace here because it would be in the namespace of the virtual cluster. To limit the resources usage of a virtual cluster, you can set limits to virtual cluster. In fact, you can do it in several ways, in fact, in two different ways. The first way, by creating your own resource quota in the namespace created by the virtual cluster, and also define a limit range that will define a default request and limit definitions to any workload that has been created without any resource definitions. So for example, here is an example of a resource quota. So no surprise, we set a limit in terms of memory, in terms of CPU, in terms of number of pods. Here is an example of limit range where you define, in fact, the default requests, CPU memory and CPU request, and the default limit for CPU and memory. Otherwise, this can also be done automatically when we are creating the virtual cluster using a configuration related to isolations. So here's an example of an isolations. In fact, we disabled the isolations, but we're taking advantage of the resource quota that we enabled and the limit range. To access your virtual cluster, you can do it in several ways. If required, you can expose the virtual cluster API by creating a load balancer role. It means that we would need to configure kubectl to connect to this cluster. We can do that with the CLI that has specific options to expose the vCluster. So here is an example: vCluster create, the cluster name, and -- expose. Then you can simply need to use the command vCluster connect to connect to that cluster, and then you will be able to use kubectl as you were already connected to that cluster. And at the end, once you want to disconnect from this virtual cluster, you simply do vcluster disconnect. If you're not able to use the vcluster CLI, not a big deal, because you can retrieve the kubeconfig file by extracting the content of the secret sitting in the namespace created by the virtual cluster. So here is the command. We get the secret vc- the name of our cluster, and then we get the template with the data config that is basically the kubeconfig. Then you will need to create a port forward to the vcluster pod to expose the API of the virtual cluster and be able to use kubectl as expected. All the other options, because port forward could be quite painful, you can deploy a load balancer service attached to the vcluster stateful set. Observing a virtual cluster does not change much from observing the host cluster. Like explained, the syncer will create pods, config map, and more in the host cluster, so those workloads will be visible anyway in the main cluster. So if you deploy any observability solution in your host cluster, then the solution should be able to see the pods running in each virtual cluster's namespace. The only limitation is related to the naming of the pods, because it will change if you're using the default settings. The pod created in the virtual cluster will have a specific naming, and then those pods going in the host cluster will have a naming with the namespace inside it. It's a different type of naming. So it could be sometimes a bit annoying to look at the workload that has a different name from the one that our developers or our team has been created in that cluster. Same constraints if you're using a log agent such as Flintbit or the OpenTelemetry collector. A log agent will read the log produced by our pods in the node folder var log pod, and then there's the container and so on. So the pod name would be the one available from the host cluster and not the one from the virtual cluster. So if you want to avoid this difference in terms of naming, then there is a specific configuration of your virtual cluster that will keep the naming of the pods. And here is the settings. So basically a post path mapper enabled true. It means that your logs pod naming would be aligned with your workload sitting in the virtual cluster. If you have a dashboard with metrics, logs, filter or split it by deployment name, daemon set, then those filter won't work properly because you only have the pod that is synced with the host cluster. So we will lose this notion of deployments, stateful sets into our metrics or in our traces. Otherwise, all the Kubernetes events of our virtual cluster will end up anyway in our host cluster. So we are getting at least a good understanding of what is happening in the virtual cluster. If you're using an OpenTelemetry collector to collect metrics, traces, logs, there is a Kubernetes attribute processor that will enrich the telemetry data with extra Kubernetes metadata. But keep in mind that all the deployment name, the stateful set, everything related to the workload, like explained before, won't be available, so won't be exposed in the host cluster. So you would need to create a specific role for a workload coming from the virtual cluster's namespaces. Using collector with vCluster could be done in two different ways. Either run a collector in the virtual cluster that will get the data from the virtual clusters and then push it to the observability solution, but you will have a reference of a namespace in those traces that won't be in our observability solution, except if you deploy an agent in the virtual cluster to report the health of the entire virtual cluster, but that sounds a bit expensive just for virtual clusters. Vcluster has been designed to build, to test our applications. So my recommendation is to use the minimum components in the virtual clusters to keep the common tools in the host cluster. So all our observability agents should stay in the host cluster. If you're running an OpenTelemetry collector, I would recommend to deploy them in the main host cluster and then map the host service in the virtual services. So for example, here is the mapping rule we presented a few minutes ago for the OpenTelemetry collector. This means that the virtual cluster won't have any collector, but the network route, DNS, will be created, allowing my application running in the virtual cluster to send the data to the main collector. It's going to be the same approach if you're using a remote write feature from Prometheus. To be smart, rely on your own Prometheus server sitting in the host cluster and create the mapping rules to expose the Prometheus server in the virtual cluster. Otherwise, the Vcluster stateful set also provides metrics related to the behavior of the syncer and of key3s. So we could imagine to scrap those information, but to do so, you would need to configure your scrap config to use a service account token and authorization headers. This is the settings in the scrap configuration. So here is an example of a scrap config. In this tutorial, we'll deploy the OpenTelemetry demo application into a virtual cluster. So the virtual cluster will only have this workload, and that's the only thing we'll have. All the other tooling, the observability solutions, will be in the host cluster. We will create a virtual cluster that will have some limited resources, a service mapping rule to let the OpenTelemetry demo send the data to our collector sitting in the host cluster, and of course, the map of the naming of the pods with our host cluster. In the host cluster, we will use the collector to collect traces, metrics, and logs from the cluster. We would deploy Prometheus and Dynatrace. The objective is to show that few default dashboards won't have the right dimensions or to be able to split or to filter the data from default dashboards. For this tutorial, of course, we will need, of course, a Kubernetes cluster as usual, the cert manager, which is a requirement for the OpenTelemetry operator. We'll deploy the Prometheus operator to have Prometheus and Grafana. We'll deploy the Dynatrace operator. So if you don't have a Dynatrace tenant, not a big deal, you can start a new trial. And last, we will need the Vcluster CLI to create our virtual cluster and deploy the OpenTelemetry demo.
Like every tutorials that we deliver easy to observable, there is always a GitHub repo. As you can see, we're looking at the repo related to the Vcluster episode, of course. So like explained, we're going to use Dynatrace, Prometheus, and other solution in this tutorial. So the first thing that you need to do is to, if you don't have any Dynatrace tenant, is to start a trial. It will get you to this page. You put your email address and you will get a tenant for a couple of days, 15 days, I think, if I'm not wrong. So once you have your tenant, a few things we need to do. We're going to deploy the Kubernetes operator and which requires an operator token and also to ingest data. And that API token to ingest data will be used also for our OpenTelemetry collector. So if you go to Dynatrace and we're going to jump into on the left bottom down menu, access token. And in the access token page, we will click on generate token. And then you will have to say, let's say operator token. And then you will search for the various scope that I described. So the create active gate token. So just simply search it. That's the old one. Once you have all those scopes selected, you click on generate token. And then once you have the token, copy that value because you will need later. So that's the first token. The second token is called the ingest token. And this one will, of course, we could say type ingest. And we will need events, logs, metrics, and traces. Those are the fourth one. So metrics, logs, event, and read metrics will be also required. So again, this once you have the the other one was not selected. So you have to remove the one from the operator token, of course. But once you generate, you will have at the end 2 tokens, and that you will save into those 2 variables that we will use for the deployment script. The second requirements for Dynatrace is to take the URL of your tenant, which is on the top here. Once you have it, you will save it into a file, and then of course you will clone the repo, and then we will install the Vcluster CLI and you will deploy it. So what are you expecting once you have deployed everything? So first, in Dynatrace perspective, it will take a few minutes, but in my case, it's already deployed. But in a few minutes, you should see at least the cluster itself. So if you go to Kubernetes, you can see that we have the Vcluster available. One thing important, if you, in my case, it's been done, but there is the cluster settings. In the cluster settings, make sure in the monitoring settings that you have the persistent volumes, the workload, the events that are selected. So then you will get everything. Once you have that, once you're in a cluster, you will see, of course, the nodes, the namespaces, the events, and so on. So that's what you should expect from a Dynatrace perspective, because the operator should pick up what is currently happening in the cluster once we have deployed it. Then the second piece that we need to do is in the cluster itself. So at the moment, what is being deployed is the OpenTelemetry operator that comes with the cert manager. So those 2 pieces will be there. The Dynatrace, of course, namespace for the Dynatrace operator. And in the default namespace, if you look at the pods running in the default namespace, you will get the entire Prometheus stack. And also we have the hotel collector that is also running here already, because then this will be used once we create our virtual cluster. So now everything is ready in place. We just need to deploy a cluster. Before we create the cluster, let me show you the various settings that we have done here in this for this tutorial. For this cluster, we will enable a few features. So in the Vcluster manifest, this is where we're going to see all the various things related to that. The first thing that we have here is the value files that could be used for Helm, but we can use also for the using the CLI. So we will expose, we'll do a metric proxy server that will have a metric server, which means I can query from the host this metric server as well. I have the host path mapper, so then the object names are aligned. It will be easier for us to look at Observability solutions to see the real pod and the logs, like explained. Sync, we will sync the nodes. That is required when you deploy the metric server, very important. We will, I didn't show you, but let me show you, because we deployed the collector in this environment. If we look at the services in the default namespace, we see that we have the OTLD collector already running here. And this is going to be the reference. So the OpenTelemetry demo that will be deployed in the virtual cluster will basically send the temperature data to this endpoint. So we need to create this service to be able to send the telemetry data of the demo sitting in the virtual cluster. Then what I also wanted to do is to put some resource quota in this given virtual cluster and some limit range to avoid having, I don't know, some surprises in the terms of resource usage on the host cluster itself. So that is going to be used. So to deploy, to create the virtual cluster is going to be a very simple command. We're going to name it hotel demo. If you do kubectl, get namespace, you will see that we don't have the same namespace as before, because now we are currently in the virtual cluster we just created. So which means now I can simply deploy the hotel demo application. So I will create first, and then of course. Now, what we can see here is that because we did the services, if we look at the SVC running in default namespace, we have our actual mapping services, which is here. So this is just the bridge between our actual OpenTelemetry collector sitting in the host. So that's the virtual service that will make the connections with the host. Now just look at the pods to make sure that they are being deployed. So yeah, they are currently being deployed. So everything should be smooth in a few seconds. So now that we've done that, we could technically disconnect. And now we are back to the main cluster. Here it is. And now you can see, now we have, because we have this cluster now, we have a Vcluster hotel demo. And we can see that we have the core DNS, so the DNS component that will do the bridge between with the services. And then we have all the workload that we just created a few seconds ago in the virtual cluster. So the pods, in fact, there's no deployments, but only the pods. And last, we have the actual stateful set for the Vcluster. So key3s and the syncer is actually here. Now, if we do get SVC, we have we can see that we have the load balancer for interacting with kubectl with this cluster. We have all the services created from the OpenTelemetry demo perspective, and last we can see that there is the 2 nodes. So that's basically to sync the nodes. There is 2 extra services that has been currently created. And by the way, let's have a look at this pipeline that is currently running. So if you look at the pipeline from the main collectors, this is the one. And you can see that there's various things. So here in this pipeline, we will have a processors, Kubernetes attribute. So we will miss the deployments and so on for the hotel demo. We have the memory limiter, the resources, some transform, and then we have receivers. So receivers will be the file log. So we will scrap or collect logs from the cluster. So we should see the logs from the hotel demo coming in. We have receiving OpenTelemetry, of course, and Prometheus. We are scrapping our own endpoint to get the collector metrics. And by the way, in here, of course, we're exporting it back to Dynatrace through the hotel HTTP. And if you look at the bottom, it's the telemetry. We have enabled the address for the telemetry with the pod IP to let the collector scrap its own metrics. Now, in the documentation, there were a notion of stateful set to be able to collect it. So I tried it. So let's deploy that, but you will see it's not going to work, unfortunately. So if someone is succeeding in this aspect, then more than great, let me know in a comment. But I created a separate OpenTelemetry collector that will just sit in the specific hotel demo namespace. This one is only made to scrap metrics and its own metrics of the collector, but also I wanted to collect metrics from key3s and the syncer. So if you look at the documentation, we can scrap those 2 containers. They are accessible on 2 different ports. So this is what we're going to try to do. And for this, we need a bearer token with the service account token. So let's create it and try to do that. But to be honest, so far I've been failing this. But if you're successful, let me know. Here is the endpoint. So this is basically this collector in this namespace is going simply to send the data back to the other collector. So this one is just designed to collect locally in this namespace the metrics from the Vcluster, and that's the only thing that it's doing. So for that, let me deploy those. So if you look at the command, we will first deploy. I created a virtual service. A service that will map those 2 ports. Then we're going to create a token related to the service account that is currently being used by this service account, the service account of Vcluster. And then let's deploy this collector. If you look at those secrets, we can see that we have the hotel demo token that is created, that is attached for the service account. So this is going to be used by the main, the other collector sitting in this namespace. So if you look at the pods running, we have this collector now that is currently running. And if we look at the logs, you will see that I have some scrap config errors. We have some scrap config errors to get those data. So if you're successful about this, let me know, because I'm very curious on how to resolve that. I did not find the time right now to resolve this issue, but if you're able to do that, that will be wonderful. Next is to look at the services in the default namespace, and we have Grafana. So let's open Grafana. Let's open now the browser, and we are getting into Grafana. By the way, I didn't change any password, so it's going to be the default password of the Prometheus operator, which is prom-operator, if you're looking for that password. So there are a couple of dashboards that comes with the operator. You can see that namespaces by workload, by pods. Let's say, take the compute resources by pods. So this will work perfectly. So I can say, I want to see the Vcluster hotel demo, and you can see that we have all the resource allocations and everything. So that will be working very well. The other dashboards that are available is the same, not by pods, by workload. But again, like we should expect, if we click on this hotel demo namespace, we will see the deployment that we just created. So the collector and the stateful set of the virtual cluster. And then you can see that we can see only this deployment, but the rest of the other objects that we have, the workload of the resources running there won't be visible because, again, like I said, there is no deployment related information. So which means you won't have the data. So if you go back to Dynatrace, you will have the similar approach. So you can see first small details, but if you go to services, you will see the various hotel demo applications. So if I click, for example, on, let's say, with the traces and everything are currently being here. So if I go on product catalog, services, for example, if I look at the properties and tag, we have the service naming, and you can see that it's taking the namespace of the virtual cluster. And we don't have other details. So, and if we go, for example, to one of the traces, you know, there is the Kubernetes attribute processor. So I was very curious about if he was going to be able to add some extra metadata. But you can see here it says pod IP, pod name, but the deployment you see here is completely missing. So this is also because it is not able to get it, obviously, because there is nothing related to that. So that's from a trace perspective. Now, if we go to Dynatrace, same thing in the Kubernetes section. We can go to the virtual cluster, and we can pick, for example, let's say cluster demo, and then we can see the workload. So there's no major impact. We can see the workload, we can see the pods, we can see the containers. Everything is here. But then suddenly, if I go to metrics, and I want to do some custom visualizations, let's say, and I'm going to do the data explorer, and I want to do, for example, a pod. There's a CPU on the pod, which metrics that I usually look at is the throttle by workload. This is something that so often I use to figure out the usage or whatever. So now if I run that query, I get all the containers, CPU throttle on globally. I can split it by namespaces. That's wonderful. I can split it by pods. If I have it. No, we don't have it. So then I can basically look at, let's say I want to look at the Kubernetes workload. And here in this case, it's picking up, you can see Vcluster demo, but we don't see the other ones.
That's it for today's episode related to the virtual cluster. I think virtual cluster allow us lots of fine-grained features to limit the resources of a given virtual cluster, to be able to map the services from the host to the virtual cluster. So there are a lot of things I think that are very helpful, especially designed when you just need to dev or test our given application. I didn't present all the features of this virtual cluster, but there are a few of them that are just wonderful. Just the fact that you can pause and resume a given virtual cluster, it's just amazing. So pause means at the end that will scale down the replica of the virtual cluster to 0 and delete all the workload running. So at the end, the pods running in the host cluster will be released. So we are saving resource allocation, CPU, and so on. And if we need the cluster back, we simply need to run vcluster resume, and voila, you have the cluster back, so you can use it for testing activities. So I think vcluster offers lots of great features needed for our team to test, to code, to customize our systems, but also has the right level of observability to let us understand what is happening in our virtual cluster. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye. So see you soon for another episode.